This video discusses how to delete the last node in a linked list. As we have done in the past, there are three basic cases to consider when you delete a node on the linked list. We delete the first node, which is the front node, or we can delete the very last node, which is the node at the back of the list, and this is the case that specifically we are going to discuss in this video, or you can delete any interior node. In other words, any node that is not the first one or the last one on the linked list. There are separate videos to discuss the cases that deletes any node on the list and the case that delete the very first node. So typically, as we know, a linked list looks like this. So the things to realize is that the only external reference that we know is the reference that is called front, which let us know the address of the first node. In other words, we don't know where the last node is. There are different types of linked lists. There are linked lists which have a reference to the front and a reference to the end. But typically, a linked list only have the one at the front, like the picture indicates. Deleting the last node represents then a little bit of a problem. What's the problem? Well, the problem is that we don't know where the last node is. We know that the last node, in this case the one that has value O, is being referred by this node, the one that has value T. But we don't know where T is because T is only referred by the previous node and so on and so forth. So imagine that, again, you have a list of 3,500 nodes. So you don't know where any of those nodes are with the exception of the very first one. So to find the last one, you need to find it. Okay, so we're going to need to traverse the list in order to find the very last node. So how are we going to do that? We're going to do that using two external references in addition to front. And those external references are what we call the previous and the current. And what do? Well, the previous reference, okay, and the current reference are always going to be maintained one node apart from each other. In other words, they always follow each other exactly by one node. And what we're going to do is to start at the beginning of the list and then move previous and move current one node at a time until we find the node that is located at the last position. And for that, we're going to use current. If we do things correctly and current is referring to the very last node, as in this picture, then it should be true that previous refer to the second to the last node, which is what the picture indicates. So if everything works accordingly, then we should have then these two references the way the picture indicate. And once we have those two, then all we have to do is access the node that is being referred to by previous and set its reference to null. What it does is to delete, in a sense, the last node because we're setting this reference, this next field of this node to null, and that will indicate that's the new last node of the list. Okay? So what are the steps then? The steps are going to be, again, very simple. We're going to create a previous and a current. We're going to maintain them exactly one node apart from each other. We're going to have a loop that is going to traverse the list until we find the very last node. Okay, when we find the very last node, we should have the picture pretty much like this one down here. And then all we have to do is to set the next field of the next to the last node, which is in this case the one that has value 7, to null. But that's very easy to do because we're using this external reference called previous, as you can see in the picture, that will refer to the next to the last node. So this is a very simple statement. So the most challenging aspect of deleting the last node is indeed finding the last node on the list and using the two external references. So let me show you one version of a method that will delete the last node. Again, there are different ways of writing the same thing. You could write a method that returns void. In this case, I'm returning the front of the list. You could return the value of the node that is being deleted. Again, different versions for different methods. Same thing with the parameters. In here, I'm passing a reference that refers to the first node on the list. It could be that I don't need to know that. Different versions for different methods. So assuming that what I want to do is to return the front of the modified list. Modify in the sense that after this method execute, the last node will be deleted. And the parameter is going to tell me where the front of the list is. Let me address the two steps that we discussed. We talk about creating two external references. So I need to declare local references called current and previous. And remember, these two have to be exactly separated by one node. A logical choice to initialize the value of current is to start current at the beginning of the list. So current will refer to the same node that front refers to. But if we have to maintain previous one node behind or in front of current, then the option will be no. Previous cannot be front because then current and previous will be starting at the same place. Remember, current and previous have to be separated exactly by one node, and previous has to precede, has to go before a current. Once I have that, then I'm going to have a loop to find the last node. And to find the last node, I'm going to check for this condition. So let's analyze it. Current is the one that is going to end up referring to the last node. When the next field in the last node is null, then I know that I found it. There is only one node in the entire list, if the list has been built correctly, that has null, and that's the last one. So when I finish the execution of the while loop that we are discussing, it should be true that current is referring to the last node. So the condition that I need to check is that current next is not null, and that's exactly what I have in my while loop. I have current get next is different than null. So the loop will stop when current get next is null, when current refers to the last node. Now, to traverse the list, then I have to do two things. One is I have to update, advance the value of the previous reference. So every time that I need to advance is a two-step operation. The first step is to make previous refer to the same thing as current, and after this statement, both references are looking at the same node, and then immediately after that, I advance the current reference by one node, and that is what current get next will do to current. These two, by the way, we had seen before in other operations, specifically when we add a node on the middle of a linked list. It's also being used when you try to delete an interior node on a linked list, so you can revisit those videos and realize that we're using the same technique. Very important to understand why these two statements has to be in that order. So maybe you want to pause the video and think why that is and realize what would happen if you reverse the order of these two statements. So at the end of the loop will be stopped because this condition is false. That means that current is looking at the very last node and previous is looking at the next to the last one. So I have this picture. Current refers to the last one, previous next to the last one, and then all I have to do is to take care of this field inside previous. And that's what this statement is doing. It's simply saying, okay, let's change the value of the next field inside previous to be null. And again, remember, the rule is that only one node in the entire linked list can have its next field set to no, and that must be the last one. So I'm converting the node that is being referred to by previous to the last node on the list. And in this case, this is just a technicality on the way that I built the method. I'm just going to return the front of the list. Last, I would like to discuss a special case, right? What if we try to delete a node in a list that is empty? Then in this case, I need to return null because the list remains empty. The front of the list should be null. I started with an empty list. There's nothing to be deleted. Therefore, the list remains the same, empty. So its front is null, return null.